Welcome to this explainer. If you spend any time at all working with LLM coding agents, you already know the absolute nightmare of context windows. Feeding raw, repetitive log files or massive non-code text documents into an agent, it eats up expensive tokens at an alarming rate, it slows down your processing, and it absolutely bloats your API costs. Sound familiar? Well, today, we're going to unpack how the brand new v2.3.0 release of ast-bro completely changes how LLM coding agents process these massive text files, crushing those token costs with an ingenious new feature called Squeeze. Here's our roadmap for today. 1. Meet ast-bro briefly. 2. ast-bro v2.3.0. 3. The Squeeze compression engine. 4. Smart fallback and slicing. And 5. Agents and integration. Section 1. Meet ast-bro briefly. So, just to set a quick baseline, ast-bro is a cross-language toolkit written in Rust. It was fundamentally built for LLM coding agents, though, humans use it too, to extract the structural answers from a codebase without paying that massive token cost of reading entire raw files. Instead of forcing an agent to read every single byte of a repository, ast-bro extracts the shape of the code. It turns highly expensive questions like, hey, where in the repo does login validation happen, into cheap, targeted, single-purpose commands. The goal isn't to ban agents from reading source code, right? It's to make reading raw files the absolute last resort rather than the first. Section 2. Enter ast-bro v2.3.0. All right, let's dive into the main event. Up until now, ast-bro was primarily focused on code structure, things like AST outlines, dependency graphs, and public API resolution. But the massive headline for the 2.3.0 release is a brand new subsystem called Squeeze. And what's wild is that Squeeze is intentionally not a code tool. It's a dedicated subsystem designed specifically to compress repetitive logs and non-code text for LLM agents. This is all powered by a newly ported compressor engine, which lives right there in the codebase at src/squeeze/mod.rs. It's a total game changer for how agents handle noisy text data. Section 3. The Squeeze compression engine. So, how does it actually shrink these files down? The newly ported compressor engine runs through a highly optimized 5-step pipeline to turn huge logs into a smaller, reversible form. First, it does a leading zero trim and timestamp dictionary extraction. Second, it extracts repetitive components and keys. Third, it moves into a byte pair encoding style token compaction. Fourth is macro templating, and finally, fifth, it finishes with consecutive line deduplication. The end result is a compact legend plus short tags. But here's an absolutely crucial engineering detail. The v2.3.0 update replaced previous non-deterministic hash maps with lexicographic tie-breaking. That means fully deterministic tag assignments. Your agents get stable, predictable tokens every single time. No more hallucinated duplicates. Essentially, raw text files, say a bulky lib.rs file or a massive log, flow straight through that central squeeze command. It takes a heavy, dense block of text and passes it right through the compression engine to become a highly compressed, token-saving output. All the heavy lifting is completely finished before the data ever reaches your agent's context window. Section 4. Smart fallback and slicing. Now, you might be wondering, what happens if compression doesn't actually save space? Well, this is where the engineering really shines in 2.3.0. The developers built a centralized emit decision logic in src/squeeze/render.rs called the degenerate floor. It's basically a smart fallback. Before sending anything to the agent, the system compares two things: the size of the squeezed output, which includes the byte overhead of the legend marker, against the size of the original raw text. If the compressed output plus the legend is somehow larger than the original text, it just smartly throws its hands up and falls back to the raw version. You are literally never penalized for using the tool. It guarantees the most token-efficient output possible every single time. And it gets better, because 2.3.0 also introduces line range slicing. If a log file is 1,000,000 lines long, handing an agent even a compressed version of the whole thing is usually massive overkill, right? Now you can clamp down on a gigantic file by passing an optional one-indexed inclusive line range. So by simply passing an argument like 100 to 100, ast-bro will process and squeeze only those exact specific lines. It feeds only what the agent actually needs to resolve an issue, completely ignoring the rest of the noise. Section 5. Agents and integration. So how do coding agents actually interact with this? ast-bro is designed to sit directly inside agent workflows, and v2.3.0 exposes the new squeeze tool to both human users via the CLI and agents via the Model Context Protocol, or MCP. There are some specific arguments exposed here. Path is the file to read. Range is that awesome line slicing feature we just talked about. You also have raw to intentionally skip compression if you ever need to. But most importantly, agents have total programmatic control over the output format using the JSON and compact flags. When requested, the output isn't just human-readable text. It's delivered as tightly packed JSON perfectly formatted as ast-bro.squeeze.v1. Putting it all together, this update gives you a unified, incredibly powerful toolkit. You've got the new squeeze command, the ported compression engine, the smart fallback degenerate floor, line range slicing, and full CLI and MCP integration. And crucially, this release also ships with comprehensive documentation and end-to-end tests to support all these new agent workflows, making it a robust, production-ready edition right out of the box. Which brings us to our final takeaway. With ast-bro 2.3.0 making log reading vastly cheaper, mathematically deterministic, and structurally way more efficient, the only question left is, when are you going to update your agent's toolkit? Stop letting repetitive logs devour your context windows and bloat your bills. Thank you so much for joining me for this explainer. Now go squeeze those token costs down to size.